Hey, what's up? Spencer. Doing kind of like an online thing today, kind of showing people. I get hit up about these educational companies that want me to like work for them or make videos online. All right, what's going on today? It's Spencer Bray. We're talking about spray equipment, spray calibration, and resistance action committee and modes of action. A lot of you are looking at this and you're looking at it going, what the hell does all that mean? That's fair, dog. I feel that. I felt that way at one point. Let's cruise through this together, dog. Maybe we'll learn something. And if like we were in person together, maybe we'd learn something about each other, right? I always love hearing about people's experiences. It helps everybody. So let's start off. Resistance Action Committee. So these are specialist technical groups that provide coordinated industry response to prevent or delay the development of pest resistance. Groups working together to provide technical data to industry to improve use of chemical technology. Simply put, an IRAC quote, we'll get into what IRAC is. Successive generations of a pest should not be treated with compounds from the same MOA group. MOA means mode of action. That's the chemistry in the product that works, right? So everybody knows that you don't use the same thing over and over to kill something because it might figure out a way to not die from it, right? That's why we develop a resistance action committee. A bunch of nerds come together. Not nerd, it's not professional for me to say, but I'm on social media. This is an example how I teach. If you don't like it, that's fine. I bet you a lot of people want to be in my class because my classes are full. So it's a bunch of really intelligent people getting together, putting things together and making sure we don't have issues in the industry. It's kind of like the people behind the curtain that you don't really know exist, but they protect human health. These people are really important. So we got IRAC, HRAC, and FRAC. These are all different insecticide resistance action committee, herbicide resistance action committee, fungicide resistant action committee. This one just does insecticides. This one just does herbicides. This one just does fungicides. And then these are all their different group links that I put in Chrome extensions. And then below here, if we take a look, we'll actually click this video right here. And this will come up.
You don't write anything down.
That's actually not the video that we want. It's this video. If you are to watch and want to learn this in my class, we will actually all watch it together, okay? So during, like, when I host class in person, that I'll typically, like, have that, hold on, here we go, all right. Then we'll watch that video together and we'll learn in depth about that. So today we're also going to watch that video, which is 4 minutes long, and then we're going to watch these 3 videos, right? The first video is how organophosphates affect insects. Organophosphates are nerve agents that affect acetylcholinesterase in movement in your body. The second video we will watch is Class 3 IRAC effects on insects. So this is a different nervous system pathway, right? Acetylcholinesterase. This one affects a secondary nervous system pathway. Finally, we learned on the past slide, this video here, what these IRAC, HRAC, and FRAC groups, now we know how the chemicals work. Then we learn about resistance, why we shouldn't apply these chemicals back to back. If I hit escape briefly, and did this not work? Pardon me, I will have to go on here, display settings. I will have to duplicate these, keep changes, and we're good to go. All right, we are back on because I hit escape or something. So this will be the first video that we watch regarding the slide that we're on. So this will be how organophosphates. This video is called acetylcholinesterase and insecticide inhibition. The second one regarding class 3A nerve agents is called pyrethroid action. By the way, all of these videos are by Larry Keeley. This guy is awesome. He really knows what he's doing. And then the final video of that slide will be number 3, insecticide resistance on a molecular level. So, back to the presentation, y'all. All right, we hit here. So, done that one. We've done this. This is where we left off, right? We just saw the 3 videos. You guys know how to find them. Now we're going to switch off from that. We're going to talk more about pest identification, right? We're going to switch it up just a little bit. Now, before I even get to this like insecticide resistance, all these different things, we got to learn what the weeds that we deal with the insects and mites that we deal with the diseases and the fungi that we deal with, vertebrate pests and wildlife and nematodes. Well, before we can do any of that, we need to learn how to send in samples for pest ID, right? So certain things you can take a picture of, other things you may need to send a sample in, right? So for different types of mailing in and record keeping and identification, there are different pages in these UC publications. So for this, we have specific directions in landscape maintenance and pest control. This is just an example, right? Because like not everybody does landscape maintenance pest control. You're going to have to find out what publication fits for the industry that you work in, right? This is just an example. So for this, if I'm working in landscape maintenance pest control and I want to know how to send weeds in, I go to page 13 and I read it. Same for number 3, number 4, number 5, right? I put some notes on there to give you an example of like how you do this, right? With insects, you got to put them in alcohol. With nematodes, you actually have to get soil and roots, right? With disease pathogens, there's a whole mess of things. So I like to talk about that very briefly. Sample information, right? Your name and contact info, date and location of sampling, description of the problem, symptoms, areas affected, and then have you treated it with anything? Like, did you spray shit on this? And then, because like if you send it to the lab and you're like the lab gets weird results and they're like, this doesn't make any sense because they didn't know what was sprayed on it, right? So let them know. Also for their safety too. You don't want to put wild shit on there and then get exposure to it. Next, you're going to take a look at sending samples in the mail, right? Using Ziploc plastic bags is what I prefer. I like to call the people ahead and be like, hey, I got samples coming. There's like X amount in there. So they know, right? Because if you're like, hey, I sent 3 and they only got 2, that's a problem, right? I also like to send things early in the week. So Monday and Tuesdays are when I like to send them out. I don't like my shit to sit over the weekend. I feel like it makes the sample not good. And then any information you have about samples and your contact info should be in the box. And then be sure to send parts useful for a specific type of sample. Don't waste everyone's time and not know what you're doing. So labs used today, I like 2 in particular for this type of analysis. I like Waypoint Analytical and Primus. Here's the Primus Labs extension. And then if you want, you can Google Client Water Sampling Guide for Microbiological Analysis. So we do a lot of food safety stuff, so we're always taking water samples, right? That'll give you an idea of like how rigorous all this is, how to the T you have to follow everything. All right, so now we've talked about pesticide resistance, right? Just because I love to talk about that. Next, we talked about like how to take sampling and things like that. Now, let's like turn over to look at like application equipment, right? I know these are 3 completely unrelated wild things, but I'm just trying to show like people who are shopping me as an educator the variants of which I can teach, all right? Let's get into application equipment, right? So spraying liquids, all right? So this is going to be foliar applications of products typically, right? So a lot of this is going to be pressurized pumps using CO2, a hand pump, a battery, a gas-powered motor, or a PTO, which is like I believe it's called a power take-off, and that is like a tractor on the back. It's got that spinning unit. That's an energy source, powering mechanism. So you like put things on it that spin around, and then it powers that thing on the back. And then also with CO2, you're typically going to see that with people that are doing research. I don't really see a lot of CO2 in field shit. The CO2 ones are meant to keep things under like direct pressure immediately. All right. I'm going to skip the bottom because I don't feel like it. All right. Spraying liquids, small hand sprayers. So the types that we're seeing, right? I see aerosol cans, hose end sprayers, right? So those sprayers that you put at the end of a hose and then it's got like a little bucket. Some people even use those for like washing their cars. I really like those. I use those a lot in my personal pesticide application. I use a lot of PFR 97 and a lot of Ancora through those. Next, you have a trigger pump. This is going to be like a hairspray thing, like I think that's what it is, right? They call it RTU, ready to use, right? RTU, ready to use. Then you have compressed air. That could be a hand pump or a CO2. Following that, a big popular one that we see is a hand pump backpack or an electrical backpack where you like do the thing on the side, like, All right. And then finally, you got your wick applicator, which is not a spray, but I like to highlight that. It's a stick, right? And at the bottom, you fill the stick, it's all hollowed out. And then there's just like a wick that goes there, and you can just go through and wipe that on weeds. It's like not super great. Next, here's a selection guide for powered liquid pesticide application equipment. It talks about all the different types, uses, formulations, and then comments on these things. You don't really have to know this stuff. I just include it for the people who like to overachieve. All right, so spraying liquids. We got large power sprayers, powered backpack. So that's going to be the backpack that I was talking about earlier. We have our low pressure. So our low pressure is going to be anywhere from 20 to 40 PSI. Anything below that, we call that, I like to call it ultra low pressure. Then we have our high pressure, our 100 PSI plus. We have handguns, boom spray nozzles. With these, 100 PSI plus, drift can be a problem, right? The biggest ones I see for drift are grape fields, grape orchards, and citrus fields, just given the nature and high pressure of the spray equipment. Nowadays, we have electrostatic sprayers. That's a negative charge on drops, and it attracts it to plant leaves. Funny thing is, though, we used to use them in these metal greenhouses, and like a lot of the material would stick on the metal pipes. Kind of funny. Now let's look at pictures. That's a 3-gallon hand pump sprayer, very typical. You see a lot of home pest people use those. That's going to be your backpack sprayer. This is a backpack sprayer with a battery on the back, so you see these do not. This one does, battery, right? A lot heavier. We have an electrostatic sprayer technology. So electrostatic creates a charge that has some type of positive cationic exchange. I don't use them a lot. I really don't understand them, but they exist. Electrostatic boom sprayer. It's going to be more along the lines of these, right? It's got this big tube that it goes through versus the old style sprayers. We also have more electrostatic sprayers inside of greenhouses. So here we have your conventional high volume sprayers out of an airplane versus a Spectrum electrostatic sprayer. What they're trying to sell here to you is a more uniform, less likely to drift pesticide application that settles, and literally it's very incredible to watch. It just falls straight down. It's very beautiful to watch over a time span. Here in our class, I would watch 2 videos. This is going to be a fixed wing aircraft guy doing really low sprays. And then here's going to be a helicopter application. Those are usually a fun time in class. Now that we've talked about sprayers, now let's talk about how like we incorporate different things, different sprayers into a program, right? So this is going to be the example of an herbicide rotation on tomatoes or bell peppers in the Southern California area that I live in. So these are industry standard rotations. These may not meet regulatory standards at the time that I give this presentation. Whoops. All right, so We got 4 pesticides: Roundup, Gramoxin, Basagrand, and Sandia, right? We're going to use boom and backpack sprayers for the Roundup, right? I want to use a real high rate of that Roundup. I use about a gallon an acre. Sometimes I'll knock it up to 2, depending on what my budget is. Roundup's whatever. It's not that great anymore. I'm honestly, my main thing is I'm going to come through and knock down with Gramoxin, right? I'm going to run 2 pints per acre. I'm going to make that shit hot. I'm going to fire that mixture up with a chemical substance that spreads it and makes it penetrate into plants better, so it burns the shit out of them real quick. I don't like employees handling Gramoxin, so we're going to boom spray it so they stay away from it, right? Then we got our Basagrand, right? That's going to be our label rate that we use, and I want it for overhead control, and I want broad spectrum application. So I'll come through, I'll do a round of Gramoxin, a round of Basagrand, right? Then I'll come through, I'll hit it with 2 shots of Roundup probably. And then once we plant, we go through, I'll start doing Sandia through backpacks only, right? So here we got 2 separate things. We got backpacks and we got booms. We got chemicals that just use backpacks. We got chemicals that just use booms. We got a chemical that uses both, all right? So that's what we're looking at. We got small volume sprayers. This is your trigger pump. This is your bicycle tire side pump or trombone pump. This is a hose end sprayer. We talked about that earlier. This is our large volume sprayer, right? That's your high output, larger sprayer. We have a boom sprayer on turf grass. This is a large volume sprayer up close of a large tractor conventional overhead sprayer on a boom. Now we're going to talk about nozzles, right? Big deal, a lot of technology in nozzles. We have flat fan nozzles that spray flat like this, and then they have different pressure, and then they also have different droplet spectrums, right? So the droplet spectrum changes due to the amount of pressure you're putting through it, right? So at 20 psi, these get a little bit bigger, right? The water droplet size coming out the nozzle. But at 60 psi, when you crank that up, it makes those like water droplets a little bit smaller. Also, your spray angle based upon incoming pressure is going to be about 80 degrees to 110 degrees, right? So your pressure range is going to be from 20 to 60, depending on what you're doing and how you like it. Now, if you don't like flat fan nozzles, you can switch over to a cone. What kind of cone nozzle do you want? Do you want a solid cone or do you want a hollow cone? It's all dependent on what you're trying to do, right? If I'm doing at-home pest control or something like that, I'm probably going to go with a solid cone spray, right? But if I'm doing Christmas trees or ornamental or something like that, I might want to go with a hollow cone just so I don't waste a lot of material. Now we got our large boom on tractor. We got to take a look at that, right? Spraying liquids, your nozzle types, depending on material sprayed, spray pattern, volume applied, also the orifice size. Also, you got to take a look at openings, wear after use, right? After you run so much material, all these pesticides, all these petroleum products, they're going to wear all them things out. So you got to know what kind of material are these things made of. Brass, stainless steel, aluminum, plastic, tungsten, or ceramic. I'm going to be a guy that prefers either ceramic or plastic. I just like ceramic and plastic nozzles. Why do you like plastic nozzles? Because they break. I like shit that breaks. Then we replace it, right? Something that just runs like okay. Like the ceramic nozzles will work a long time, but they'll start farting out on you or spraying too much depending on what you're doing with them. Next, we got our spraying liquids. We got our nozzle patterns. So we have our flat fan, even or tapered. We have our cones, hollow or solid. We have solid stream, and we have flood. The way you look at your nozzle patterns is you have a pressure rating, and then you have your volume rating. So the first 2 are going to be pressure. The last 2 are going to be volume, all right? Typically, it's 1 decimal point over for the volume. If I'm not correct there, let me know. Now we're taking a look at 10-degree nozzle alignment, right? You got to make sure that all your nozzles are correctly aligned. If they're fucked up like that, if they're too open or too closed, look at how your pattern changes. You want your shit to be like that. That's where you're making money. You do it like this, you're fucking off someone's money. That's not good. You're doing it like this, you're also losing money. That's not good. All right? So you got to make sure you're properly aligned. Look at how that goes. Perfect, like fucking glass, man. That's how you want that shit. You want that fucker tight, all right? You don't want it like this, All right, that right there, that's an issue. That's an issue. You're losing money right here. You're making money right here. Never forget that. All right, here you see, this is what the nozzles look like if you're laying underside of it. Look at how they're ever so slightly turned uniformly. That thing turned over, look at how that meets. Edge to edge, perfect coverage. It's going to be your direction of application using a boom sprayer. Perfectly that way. Move it down. Other liquid applications, you're going to have soil drench, soil injection, tree trunk injection, tree trunk implants, and poison baits, not liquid ones. Here we have an example of different types, uses, formulations of non-powered and hand-powered application equipment. Here we have soil drenches. As you can see, this person here is holding a large device. Out comes a rubber tube. It is connected. He's going to place that in the ground, make soil injections. That's a large scale, high volume, high commercial unit. Next, we're looking at a smaller commercial unit. This is going to be a soil injector. You walk around with that machine, place it in the ground, it dispenses an amount of material in the ground. You have tree equipment, tree injection, and tree implants. These are syringes that you just stick into the tree. Follow these instructions right here. Over a period of time, it just slowly injects that material in, protecting your tree. You also have granular applications, whether it be insecticides, baits, or drops, and you use either drop spreaders or rotary spreaders for these. That's a rotary spreader, right? It spins it, and then as it flicks it. Here, we have a drop spreader that drops it directly down, just uses gravity. I find these to have much more precision, but it takes 10 times longer. I like to haul ass with one of these and just do it quick, right? This takes time. Application equipment. We have bait application. You do it through rotary spreaders, underground gopher bait tools, right? Maintenance of equipment, right? Wear protective equipment. All right, pause, refresh, refocus on what we're talking about. We're moving so fast. Now we're talking about the maintenance of equipment that uses pesticides. All right, maintenance of equipment that is pesticide related. Wear protective equipment. Gloves and eye covers, dust masks are, in my work, required. Clean and decontaminate tanks. Oil, check hoses, worn nozzles, everything needs to get checked. I want screens pulled out of that thing. Never leave a spray mix in the tank, right? Basics. Sprayer calibration. I don't really want to go over this right now because it's better to do in person. Mix the exact amount. Don't pour shit down the drain. Don't be fucking dumb. All right? I use profanity. Why? Because this class is for people who are 18 and over. Don't be fucking dumb. Don't make my industry look bad. I seriously will be fucking pissed off. Don't do this dumb shit. All right, next, sprayer calibration. You can take a look at this. I'm not going to teach it right now. It takes too long. All right, landscape maintenance, pest control. If you're looking for things to study, if you want to learn more, you want to learn more about calibration, you will go here to the A&R catalog at ucdavis.edu. This is what it looks like in the books. All right, now part of my class is, I just want to give you guys a brief thing of our final, this is how it would be in the class that I teach. Our final exam looks like this. This is going to be the last exam, classes 5 through 10 plus calibration. Chapter 5, this is pesticide handler safety. This is everything we learned in Chapter 5. Chapter 6, this is field worker pesticide safety. This is everything we learned in Chapter 6. Chapter 7, fumigation worker handler, right? This is everything you need to know for that. Pesticide residues, everything you need to know for pesticide residues. Chapter 9, we have to learn in this class about endangered species, Healthy Schools Act, Water Act, and Dormant Pesticides Act. It's everything here. Next, Chapter 10, minimal exposure pesticides. This is everything you got to know. All right, I mainly want you guys to focus on closed systems and respiratory protection in regards to MEPS. All right, that's it for today. Later.